Hello everyone, I'm trying to use OneNote to do my next lecture on trigonometric identities. We do know some of them already, right? I'm going to write down the basic ones. Tangent of theta equals sine of theta divided over cosine of theta. Or we do know that sine square of theta plus cosine square of theta equals 1. We also know that 1 plus tangent square of theta equals secant square of theta. These are three identities I was asking you to memorize, right? We also do know that secant of theta is 1 over cosine of theta. In this section, we are going to learn more identities, but we're not going to memorize them like these four. We're just going to play with them just for fun. So I'm going to start with first example number 1. And usually, guys, identity looks like equation. And for example, cosecant, I pressed something wrong on my pen, right? Cosecant of x multiplied by tangent of x equals secant of x. Usually identity has left side and the right side. To prove identity, we can either modify left side or modify right side or modify both of them. But at the very end, we're supposed to get a true statement, something like 1 equals 1 or 0 equals 0 or cosine equals cosine. Let's see how it's going to work with this identity. So what is cosecant is 1 over sine of x, right? Tangent is sine of x over cosine of x. I'm modifying the left side of identity. I'm going to keep the right side for a while. So what I see, I can cancel sine and sine, and I'm getting 1 over cosine, right? Right from over here, I remember that it's exactly is secant of x. So I can write down secant of x here equals secant of x here. You see that we got a true statement at the end. So that's how identity proofs are working. Okay, I want to make a pause and move to my next example. Okay, we continue working with identities, and I'm going to prove another one. It's going to be tangent identity. So 1 plus tangent of theta divided over 1 plus cotangent of theta equals tangent of theta. Usually the question is going to be the true identity or false identity. Well, what I'm going to do, I'm going to work on the left side. I'll try to modify it using identities I already know. I'm not going to touch the right side, so I'm just going to copy left, and see if I can get to tangent. So first I'm going to start writing down tangent as sine of theta over cosine of theta. In denominator, cotangent, which is going to make up cosine of theta divided over sine of theta. Well, I'm going to bring to common denominator both fractions, so it's a cosine of theta plus sine of theta divided over cosine of theta, and the denominator over here is going to be sine of theta plus cosine of theta divided over sine of theta. I'm still working on the left side of my statement. So left side. So what I see, the numerator here and numerator here are same, just switched cosine and sine. So I'm going to cancel it. What is going to happen to sine? Sine is going to jump up, and I'm going to get sine of theta divided over cosine of theta, which we do know equals to the tangent of theta. And that's exactly my right side, right? So I proved that identity is true. Okay, let's do one more example, and I'll show you a different way of working with identities. Let me scroll a little bit, scroll all the way down, and kind of get more space to write down. So my next example, example 3, is going to be 1 minus sine of theta divided over cosine of theta equals cosine of theta divided over 1 plus sine of theta. Well, the question is again true or false. True or false. Well, what I'm going to do is this identity. I'm not going to modify left side or right side separately. I'm going to do a proportion multiplication crisscross. So I'm going to use 1 minus sine of theta multiplied by the denominator of this fraction, 1 plus sine of theta, and on this side cosine of theta multiplied by cosine of theta. Here I'm going to use the formula a minus b, a plus b equals a square minus b square. So I'm going to get 1 square minus sine square of theta. This side I'm just going to combine these two cosines into a square of cosine. Well, we do see 1 minus sine. If I move it, this sine over this side, I'm going to get 1 equals cosine square of theta plus sine square of theta, and everyone can recognize Pythagorean identity, so which is true. Okay, now I'm going to give you one example to solve on your own. I'm going to make a pause, and after pause I'm going to consider that example. So A, 1 minus sine square of theta divided over 1 plus cosine of theta equals cosine of theta. And the second one, B, 1 minus cotangent square of theta divided 1 plus cotangent square of theta plus 2 cosine square of theta equals 1. Okay, let's see if you can do them within like 10 minutes, and I'm going to be back. Okay guys, I'm back with solutions of my questions. So I'm going to start with the first one. 1 minus sine square of theta divided over 1 plus cosine of theta equals cosine of theta. What I'm going to do, I'm going to deal with the left side. I'm going to modify it and see if I can get to the right side. First, I'm going to use Pythagorean identity on the top. So it's 1 minus cosine square of theta divided over 1 plus cosine of theta. I'm not going to copy this. I'm just going to continue working with this expression. So what I'm going to have, bring to common denominator. No, I'm not going to bring to common denominator. I'm going to use the formula a minus b. So it's 1 minus cosine of theta, 1 plus cosine of theta, divided over 1 plus cosine of theta. This one is going to cancel, and what I'm going to get, 1 minus cosine of theta. 1 and 1 is going to cancel, and I'm going to get exactly cosine of theta. We have minus and another minus, which is going to give us plus. So that's going to be a true statement. So left side is exactly equal to the right side. Maybe not very clear. I used here Pythagorean identity. Sine square of theta plus cosine square of theta equals 1. If you move cosine over here. Okay, let's move to my next example. I'm going to scroll a little bit this up. And my next example is going to be 1. I'm doing something wrong. 1 minus cotangent square of theta divided over 1 plus cotangent square of theta plus 2 cosine square of theta equals 1. This is example 2, or it was B actually. Well, I'm going to start with sine and cosine representation of cotangent. So it's 1 minus cosine square of theta over sine square of theta divided over 1 plus cosine square of theta over sine square of theta plus 2 cosine square of theta. Here I'm bringing to common denominator, so I have sine square of theta minus cosine square of theta divided over sine square of theta. Denominator sine square of theta plus cosine square of theta divided over sine square of theta. Well, I see that sine square is the same here. I know this one is Pythagorean identity and it's going to be equal to 1. So the only thing I have left is actually sine square of theta minus cosine square of theta. Plus I'm missing this term, which I'm going to move over here, plus 2 cosine square of theta. What I see, this minus cosine and this plus 2 is going to give me just 1 cosine. So I'm going to have actually sine square of theta plus cosine square of theta, which is well-known Pythagorean identity, equals to 1, which is exactly my right side, right? Okay, I think that's all for this section. Please do the homework. Hello everyone, I'm going to start video lecture on section 2.5, sum and difference formulas. I'm going to just use whiteboard. Let's see how it's going to work. I'm using my phone to record. My all previous recordings had very bad sounds. Okay, I don't think that you're gonna see me besides my hands maybe. So we are going to start with formula to memorize. So I'm going to ask you to memorize the formula for cosine of alpha plus beta. Alpha plus beta are two different angles you are going to add. And to express this cosine of the sum, we can use cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. I want you to memorize this formula. It's not very difficult to remember. Useful, very useful formula. We're going to use it many times. Let me show you an example of use of the formula. That's not going to be like a most common example, but one of the examples. So I'm going to calculate cosine of 75 degrees. Well, there is no 75 degrees in our table for cosines, right? So what I'm going to do, I'm going to represent it as cosine of 45 degrees plus 30 degrees. Together they're making 75. And after that, because I do have two angles here, I'm going to use my formula. Cosine of 45 degrees by cosine of 30 degrees minus sine of 45 degrees and sine of 30 degrees. All four values are table values, so I'm going to use them. For example, cosine of 45 degrees, it's 1 over square root of 2. Cosine of 30 degrees, square root of 3 over 2. I'm hoping that you guys still remember this after these 2 weeks of coronavirus quarantine. Sine of 45 degrees is 1 over square root of 2, and the sine of 30 degrees is 1 over 2. So altogether, they're making two fractions, and you see the denominator of both fractions is same, square root of 2 multiplied by 2. So I don't need to multiply anything by anything, I just need to kind of simplify expression, square root of 3 multiplied by 1 and 1 by 1, and copy denominator. And I got expression for cosine of 75 degrees, which is precise expression. Now I'm going to use the formula we memorized. I'm going to call it formula 1 to obtain formula 2, which you don't need to memorize. And that's going to be the difference formula, cosine of alpha minus beta. Instead of kind of getting the formula, I'm going to use formula number 1, and I'm going to represent negative beta as like negative angle. So minus beta is negative angle. So I'm going to use the formula just for the sum of these two angles, and it's going to be cosine of alpha by cosine of negative beta minus sine of alpha by sine of negative beta. Now I'm going to use the property of even and odd functions for sine and cosine. I know that cosine is even, means that cosine of negative beta is equal to cosine of beta. And the sine of negative beta, because it's odd function, it's equal to negative sine of beta. So my result is going to be cosine of alpha, cosine of beta. This minus and this minus together are going to give me plus, and sine of alpha, sine of beta. And my brand new formula is here. What I'm going to do, I'm going to use this formula to calculate something like a difference similar to cosine of 75 degrees. So what I'm going to do, I'm going to write down the problem here, and I'm going to stop my video, give you a chance to work on it, and then we can return back and do it together. So we're going to do cosine of 15 degrees. Well, I'm going to make a little start for you. I'm going to represent 15 degrees as 45 degrees minus 30 degrees. And after that, we will need to use the formula. So I'm going to stop recording, give you some time to work. And after that, I'm going to solve it myself too. Okay, so I'm hoping that everyone tried the use of the formula. Now I'm going to show how to do this. So I did copy the problem on the top, erased everything else, and I'm going to use the formula. So it's cosine of 45 degrees by cosine of 30 degrees plus, because formula for minus actually has plus over there, and that's a sine of 45 degrees and a sine of 30 degrees. All the sines and cosines are table values. So 1 over square root of 2 for 45 degrees, cosine of 30 degrees is a square root of 3 over 2, plus sine of 45 degrees 1 over square root of 2, and the sine of 30 degrees is 1 over 2. Well, again, you see denominators are same, so we don't need to multiply fractions by anything, just simplify square root of 3 multiplied by 1 and 1, and copy the denominator, and that's going to be the answer. Okay, so now we are ready to develop formula for sine. Formula for sine is going to be also memorized one. Sine of alpha plus beta is going to be equal sine of alpha by cosine of beta plus cosine of alpha by sine of beta. You see how nice and symmetrical is the formula. Both angles here are coming as sine and cosine, and they exchange cosine and sine. Let's see how the formula is going to work for our 75 degrees. Sine of 75 degrees, which is what? Sine of 45 degrees and 30 degrees, right? I'm going to use the formula. And because all these are table values, I'm going to simplify this expression. 1 over square root of 2, cosine of 30 degrees is square root of 3 over 2, right? Plus 1 over square root of 2, and sine of 30 degrees is 1 over 2. Fractions are having same denominator, so I'm just going to write them down in simplified form. Yeah, this is going to be the formula to memorize, but actually in the whole section we'll need to memorize only 2 formulas, and that's not that good. So what I'm going to do for this formula, to get a formula for difference, I'm going to apply the same method I used for cosine. So formula number 4, you don't need to memorize it, you just need to remember how we obtain it. So I'm going to represent the sine of alpha plus minus beta, and then have this sine of alpha cosine of minus beta plus cosine of alpha sine of minus beta. Again, I'm going to use the properties of even and odd functions. So I know that this one is just cosine of beta because the function is even, and this one is negative sine of beta because function is odd. So my result here is sine of alpha cosine of beta minus, there is minus and plus here, cosine of alpha sine of beta. And that's formula number 4. You don't need to memorize it. It's very easy to obtain from formula number 3. So actually just 2 formulas to memorize. I'm going to use this formula to find out sine of 15 degrees, same way I was doing for cosine of 15 degrees. I'm going to stop my recording and let you 10 minutes to try it on your own, and then I'm going to solve it too. Okay, I'm hoping that everyone tried the sine and new formula for the difference. The difference here is going to be 45 minus 30, which is going to give us 15. And I'm going to use a formula. So it's a sine of 45 degrees by cosine of 30 degrees, right? Minus cosine of 45 by sine of 30 degrees. Well, all are table values. Well, again, we are dealing with same numbers basically. 1 over square root of 2 and 1 over 2, same denominator. Numerators are subtracted, 2 square roots of 2. So not too difficult. Two more formulas, you don't need to memorize them, but it's nice to kind of be aware of them. They are both obtained from the previous formulas, number 1 and number 2 and number 4. So, formula number 5. Let's calculate cosine of 90 degrees minus theta. You see the difference of two angles. I'm going to use a difference formula, formula number 2. So I'm going to have cosine of 90 degrees by cosine of theta, right? A plus, because formula for minus has plus actually, sine of 90 degrees and the sine of theta. Again, I'm using formula number 2, which we don't need to memorize. I do remember that cosine of 90 degrees is 0, which is turning the whole thing into 0. Sine of 90 degrees is 1, so 1 by sine of theta is just sine of theta. You see, interesting fact, cosine of 90 degrees minus theta is the same as the sine of theta. Okay, and number 6. Can you guys try sine of 90 degrees minus theta on your own? That's use of the formula number 4. And I'm going to count 2, 3 and do it. And my suggestion is to stop the video, do it, and then check your result with mine. Okay? So 1, 2, 3. I'm going to use formula number 4. Sine of 90 degrees cosine of theta minus cosine of 90 degrees sine of theta. I'm using formula number 4. I know that this one is 1, so altogether it's going to be just cosine, and this one is 0. So altogether it's going to be 0. And my answer is cosine of theta. Nice symmetrical result for sine and cosine. Cosine of 90 minus theta is sine, and sine of 90 minus theta is cosine. Okay, so what else we can calculate? Well, we can get formula number 7 for tangent. That's not necessary to memorize formula, but nice formula to kind of be aware of. I'm going to write down the beginning of the formula and ask you to try it on your own. Tangent of alpha plus beta. A little clue I'm going to give you. It's that tangent is sine over cosine. And here you can use formulas for sine and for cosine. They're formula number 1 and number 3. And then simplify the expression. I'm going to pause my video and give you 10 minutes to do it, and then you kind of turn it on again. Okay, I'm hoping that everyone tried to do the formula by himself. Now, let's see how it's supposed to be done. So I'm going to use formula number 3 over here and formula number 1 over here. Formula number 3 is sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And denominator, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Well, how do we simplify this formula? What I'm going to do, guys, I'm going to divide both numerator and denominator by cosine of alpha, cosine of beta. Cosine of alpha, cosine of beta. Let's see what I'm going to get. Sine of alpha, cosine of beta, divided by cosine of alpha, cosine of beta, plus, cosine of alpha, sine of beta, divided over cosine of alpha, cosine of beta. Denominator, cosine of alpha, cosine of beta, cosine of alpha, cosine of beta, minus sine of alpha, sine of beta, divided over cosine of alpha, cosine of beta. Let's see what we can cancel here and how we can simplify the formula. So I see that cosine and cosine cancel, and this one is going to give me tangent of alpha, right? This one cancels, and this one is tangent of beta. Here everything cancels, it's not becoming 0, it's actually becoming 1. And here we do have tangent of alpha, and this is tangent of beta. So what we are going to have? Tangent of alpha plus tangent of beta divided over 1 minus tangent of alpha, tangent of beta. And that's a new formula. You don't need to memorize it. I don't think that it's difficult to obtain it every time when you need it. But some people have good visual memory, so you can memorize it. One more thing in this section, which I'm planning to teach, and I think I'm going to stop this video and teach it in a new one, okay? Last thing I'm planning to teach in this section is how to convert expressions a sine of theta plus b cosine of theta into just one sine. What are a and b here? Just arbitrary numbers. What is one sine? Well, just one function of sine. Question marks are kind of here to set like coefficients which we'll need to adjust to make this expression equal to this. What I'm going to do, guys, I'm going to divide and multiply expression on the left side by square root of a square plus b square. I'm going to explain why. A square plus b square, square root, I multiply it, and in parentheses I'm going to divide by it. Sine of theta plus b square root of a square plus b square cosine of theta. Did I change my expression by doing this? Well, if I simplify it, open parentheses, I'm going to cancel this and get a sine, cancel this and get b cosine. So that's the very same expression. How this expression is better than the previous one? I'm going to draw a triangle. Watch my triangle. I'm going to put over here b, over here a, and that's a right triangle, so my hypotenuse is going to be a square root of a square plus b square, right? I'm going to label this angle phi. I already have theta over here reserved for the angle in the formula, so I'm going to just invent a new angle phi. So for angle phi, what are going to be these expressions? Well, you see that a, adjacent side over hypotenuse, is going to be the cosine of phi, right? And b over hypotenuse, opposite side over hypotenuse, is going to be a sine of phi. And you start looking at this and you see the formula number 3. Cosine phi sine of theta, sine of phi, cosine of theta. And that's going to be the answer actually. A square plus b square sine of theta plus phi. Phi is not going to be a known angle. Actually, phi can be calculated either like cosine inverse of a over square root of a square plus b square, or sine inverse of b over square root of a square plus b square. Well, just because this one is sine, so if I put sine inverse here, they cancel each other, I'm going to get phi and sine inverse of this. Another way to calculate it, it's tangent inverse of sine over cosine, so b over a, maybe a little bit easier. Let me show you an example of how to do it. So let me see. Yeah, I think I'm going to use 2 sine of theta plus 3 cosine of theta. So how do I make up this expression? That's a square of this coefficient and square of this coefficient. So it's a square root of 2 square plus 3 square. I know that 2 square plus 3 square is going to give me 14, right? So I'm going to have over here in parentheses 2 over square root of 14 sine of theta plus 3 over square root of 14 cosine of theta. After this point, we can just right away write down square root of 14 instead of this expression, sine of theta plus phi, and we can tell that phi equals tangent inverse of 3 over 2. Well, this is kind of imaginary sine of phi, so that's cosine of phi sine over cosine is 3 over 2, and that's going to be the answer. Okay, now what I'm going to do, I'm going to stop my video. And no, first I'll need to give you a problem to solve, and then I can stop my video actually. Let me find the problem. Okay, need to erase something. I'm gonna erase this formula, okay, to write down the problem for self-work. 5 sine of theta plus cosine of theta. Can you repeat the steps I was doing with this expression? Try to work on this one. And I'm going to explain this in my next video. Okay, I hope that everyone tried this expression. So what we have? We have 5 and 1. So it's a square root of 5 squared plus 1 squared. 5 squared is 25. 1 is 1. So it's 26 actually, right? So in parentheses, I'm going to have a square root of 5 over 26 sine of theta plus 1 over square root of 26 cosine of theta. And writing down square root of 26 instead of this expression, I'm going to have sine of theta plus phi, and phi is going to be tangent inverse of 1 over 5. This one, which is sine, over this one, which is cosine. You can always use a calculator, find what is tangent inverse of 1 over 5, and use this as an angle over here. In the homework, actually, they are going to do this. I just don't have a calculator because my calculator is my phone and I'm using my phone to record actually this video. So that's all about section 2.5. I want you to do your homework, and on Friday I'm planning to give you a quiz because we are missing the previous Friday quiz. I think it's going to be a longer one, but we are going to have only sections 2.1 to 2.5 on that quiz, and I'll try to make up one question per each section. Okay, well, that's all. And I'm hoping that you do the homework. You can send me your questions in email. And I'm very sorry, my lectures are so bad. I'm not good with technology, and I'm writing down or recording every video like 5 times because I forget to turn on the sound, I forget to start recording and lots of other stuff. So I'm already doing this specific lecture like 5th time today. Okay, good luck.